3.
Let f be the function given by f of x equals 4x squared minus x cubed, and let I be the line y equals 18 minus 3x, where I is tangent to the graph of x. Let R be the region bounded by the graph of x and the x-axis, and let S be the region bounded by the graph of x, the x-axis, and the line I.
And also A?
Show that I is tangent to the graph of f of x at x equals 3.
So let's go ahead and pinpoint out where 3 might go. And then when I bring that straight up to the top, is it actually touching these 2 points or these 2 lines? So just by the look of it, we know it's going to. So I need to figure out what is the order pair of this one. It is 3 comma something. And because it's been shared by the curve and the straight line, does it really matter which one I plug it into? No. So why not plug it into this guy right here? So I have 18 minus 3 times a given 3. How many is that? How many? 9. So I know our point is at 3 comma 9. And that's our x1 and y1. And we're looking at the tangency. So we need to find the derivative. Now to find the derivative, I can find the derivative of the first one or the second one and plug in the 3. Which one is going to speed it up? The first one? I mean the second one? What is the derivative of all of that?
3.
Ooh.
Oh, the derivative.
Uh-huh. Negative 3. So we have y minus y1, which is 9, is equal to the slope, negative 3, times x minus the x1, the 3, and done. So even if I use the other function, it'll still give us the same answer, okay? Cody, what's up?
Where'd you get the 9 from?
9 came by plugging the 3 into either this one or this one.
Okay.
We'll still get the 9 on both, okay? So now let's go ahead and look at the area of the S. The area of the S is basically between the curve and the straight line, also bounded by the x-axis. And I'm going to do something weird on this one. Let's exaggerate this figure real quick. So I'm going to kind of elongate it a little bit. And you do the same thing. And I'm also going to cut a vertical line through 4. And imagine taking that figure through the vertical line and splitting it. And if you can imagine that, I want you to also split it. My picture may not be perfect, and that's okay. And there's a reason behind this that you'll find out once I explain the whole thing. I want you to highlight the top and the bottom. And we know this number, the first one was from 3 to 4. The second one went from 4 to what? 6. So let's worry about the integral of the first one. So I want you to write the area is equal to. The first one we're integrating from 3 to 4. My top equation is my linear function, is that right? So my linear function given was 18 minus 3x minus the bottom one was my curve. The curve was given as 4x squared minus x cubed, of course, dx. Now, here's a reason why I split those two. Is my bottom one part of the curve at all? Isn't that part of y equals 0? That's why we had to split it, okay? Because we had 3 different equations involved. Let's write plus the integral from 4 to 6. My top one is my linear function given. And the bottom one is y equals 0 dx. And I know our calculator is going to pre-populate the parentheses. Ooh, that's very pretty. There you go. All right. Someone type in the first one. Actually, people closer to me, type the first one. Everyone from Sam and on to the wall, type the second one for me. Don't let the quiz be the first time typing this. It's going to be awkward.
$1.916.
Can that be in a fraction? I like fractions. Math, enter, enter.
23 over 12.
Oh, 23 over 12. I like that.
6.
6, very good, plus 6. And when I add these two together, we're going to get 95 over 12. So everyone clear on why I had to split it? There were 3 equations involved.
That's why it's,
Okay? What?
I took the whole thing and I did not take it.
Let's check. I could be wrong, and that's okay. 23 over 12
Oh, no.
plus 6.
This is square
I got it.
for x.
It's my-
All right.
my fault.
The next one that I want to go over is number 5. Because this one, it looks like we kind of have to integrate by hand on one problem. All right, Alan, let's read number 5 and A.
Let R be the region in the first quadrant under the graph y equals 1 over square root of x, for 4 is less than or equal to x, less than or equal to 9. Find the area of 1.
Okay, so let's go ahead and graph this. If y'all remember rational functions, it went downward, right? Kind of. So for this one, it's got a critical point at 1. And if you're wondering why, plug in the 1 in here. 1 over square root of 1 is 1, okay? And as if it is exponential, it's going to go down in the opposite direction. And it's going to get closer and closer to 0, but not exactly. And then at 4, let's go ahead and cap it at 4 and 9. And it's only in quadrant 1. And shade them in. And it should not look like a rectangle, although it kind of does, but it should be thinner on the right. All right. So looking at this, is this with respect to x or y? Are we scanning from left to right or up and down? Left to right. So let's write with respect to x. So our integral is from, my low number is 4. High number is what? 9. And it's going to be top minus the bottom. My top is my rational, 1 over radical x, minus, what is the equation of this flat surface right here? 0. Then I have dx. Okay, someone type that in. I know, he's going to win. Go. Go. Make him nervous.
He didn't even write everything.
That's not true. What?
I'm so s-
Whatever.
Now your hand's going to shake a little bit.
I don't even care. I don't even try.
It's going to be a clean number. How many?
2.
2 it is.
I mean,
No, she's got it first. All right. On B, Gian, tell us read.
If the line x equals k divides the region R into 2 regions of equal area, what's the value of k?
So I need to find 2 equal areas. So that means I need to figure out at what x value can I cut vertically to make 1 and 1. So let's kind of guess right here. If I go right in the middle of 6.5, we know that's not going to be fair on the left side, right? Or not fair to the right, I mean. So is it going to be before 6 or after 6? We're just predicting.
After.
After. It's going to be after. Now, if you say before, that's okay. Now, any lucky guesses possibly? 6 point,
6.78.
2.7.
okay, 6.27.
6.18.
6.18?
Shoot, you're right. What am I
6.5? All right, I'm going to stop it at that. So let's see who might be more accurate. So let's go ahead and integrate. So we're trying to integrate from 4 to some number. Let's call that some number k. Are we writing? And we're integrating from 4 to k of 1 over radical x. And I'm not going to write the minus 1. So how many variables do we have on this integration? 2. So we have to integrate by hand. So we got 4 to k. Let's rewrite the radical on the bottom by bringing it to the top with a negative power. And if y'all can remember adding 1 to the fraction, we're good to go. So let's write out 1 over. What is 1 more of negative 1/2? 1/2. X to the 1/2. Then I don't need plus c because we have our bounds. So we have 4 to k. That's going to give us, this amount alone is going to be 2. So let's go ahead and simplify that. 2x to the 1/2 from 4 to k. And when I plug it in, we get 2 radical k minus 2 times, when I plug in the 4 into the x, isn't that basically 2? 2 times 2 times 1/2 is 2. 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 2 And we want that to equal 1, because half of 2 is 1. Now let's do the rest of them on the calculator. So we're doing algebra 1. We're going to add 4 on both sides. What are we dividing by on both sides after that? 2. Where's the pi coming from?
Is that not five?
That's the root of K.
Square root of k. You know,
Oh,
I'll do better. There you go.
I really thought I was really confused.
Was that really pi looking?
Yeah.
That does look like a pi, except for the little.
Okay, let's move on. How do I get rid of the square root?
Square.
Square it. 6.25. Who gave me 6.27?
Oh
I did.
Pretty good.
Don't call yourself.
So exactly at 6.25 would be even pieces. So let's write k is equal to 6.25.